partly, a good portion of what we're doing is providing a place and developing a community of learners. And that was probably very different than many of our math classes. The idea is that we're all here to learn as mathematicians and to help each other get as far as we can. Not pit ourselves against each other, but be together and support each other in our learning, because that's what a community of learners do. It's not one against the other. It's how do we help each other grow as much as we can individually. And that's why we're there. And then also, if we take a look back at the tasks and the culture of the things that were of the curriculum that was sort of highlighted tonight, you can kind of see that richness of mathematical ideas, of teachers needing to know how kids think, what's going to interest the kids. I mean, it has to be something that they're going to grab into, and then where it's going, because it can't be just a bunch of interesting things to do. It has to be, where is this leading to? And so that's at the heart, and we work we are constantly working individually and as a team to make sure that that's happening, from the from the littlest kid that comes in to the kids as they graduate and leave us. So we can open it for a few questions here. Ellen.
Yeah.
Yes.
So my question is, Sophia comes home with homework. I love math, but I don't want to help her. And she'll say, that's not the way we did it in class. So I don't understand enough to even talk to her about it. I guess that's my frustration.
So
I would love to learn what she's
Right.
learned.
So and we can certainly individually make sure that parents conferences are coming up. For some of us, they happen for others, but give sort of a cheat sheet. I have a little cheat sheet for my parents of the kinds of things. The first thing is, and remember that it's not the answer that's the important thing here. I mean, ultimately it is. They're building a bridge across the Delaware River. I want the kids to have the right answer. But the idea is the thinking behind it. So there's things that you can do, which is to ask the questions. What do you remember so far? How far can you get on your own? What questions do you have? Because much better that the kids come in the next day with saying, this is as far as I got, and then I couldn't remember. Yeah. So I think that it's very different probably than what we felt when we had to turn our homework sheets in, that sheet had to be done, and if it wasn't done, then you were getting some kind of a bad grade. Now, I want my kids to bring their homework in. All of us do. They have homework that has to come in, and we're concerned if kids forget on a regular basis and aren't doing it or aren't finishing it. But the idea is, if you've given me, and this is 5th and 6th graders, 20 minutes of really concentrated effort, and you get as far as you can. And ask your parents, but don't let your parents do it for you, because I've had a lot of kids come in, and they'll have this wonderful thing with decimals in it, and I know they haven't, they're dividing decimals, and it's like, what? And it's like you realize, oh, that's an adult handwriting there. And
with this, a lot of this. A lot of this.
You'll say, do you understand this? And they'll say, they said, do you understand? Well, do you understand what you did? Well, my mom helped me, or my grandma helped me, or whatever. Do you understand? Well, sort of. Oh, can you do it? Well, really, I really didn't understand it. And so we have to take the focus off of getting the answer in some way that makes no sense to the kid, which is often what the algorithms are, is they make no sense at the beginning of the understanding. They're efficient, and we move towards efficient strategies as we go, but what can you do on your own? And if the question is, if it's like, I forget, I don't even remember what we did, so be it. Say, all right, well, go tell Jim or Marilyn or Kelly or Alessandra that, you forgot, and it's okay to have forgotten.
So that's the message they go home with? And
and that's why we never give them overnight homework. We give them several days.
I give overnight homework.
I always give several days, because I want them to get used to the idea that, let's say you're absolutely lost, that, that's part of the reason we use first names. We want to be as approachable as possible. And that when you ask a question afterward, that shows that you're dedicated and you're ready to go. And that kind of like avoiding, a question is just the opposite of what we want, So that was, anytime anybody has a question, I tell them, I'll work with you at any time. But it's not time.
Sorry.
No, go ahead.
I even had with some of our 8th graders, the graduates, I wanted to see what they would do with a really difficult algebraic problem that I didn't know if they had seen before, or it had some tweaks in it. And so I took an algebraic equation, and I had them, a linear equation. I wanted them to write a story problem that it would represent. And I said, and I wrote right on it in their, or had them write in their notebooks, I promise that this will be my work, even if it is blank. And so the parents knew that I don't want you to help them, I don't want your older sister, I want to know what is in your head, because that's ultimately what helps me as the teacher, you know, sort of guide the learning. So yeah, I think that's a message the kids get across the board.
Right, right, and also often what we focus on is, if you can just, the mantra that I have is, it's got to make sense to the kid, and if it doesn't make sense to them, just getting an answer is senseless. It's like Alessandra talking about the person who said I have a dream speech. It's meaningless. It's those illusions of learning, and then they really can't use it for anything else.
And then we want to know.
Yeah,
Because we want to be able to help them,
Right,
and
right.
that's the goal, so.
Yeah.
But I think more to your point too, Ellen, there are ways of recording that probably are different, that you'll start seeing coming home, all of you, no matter, that will look different than maybe the way that you record it.
Sure, no, I'm expecting that.
Right, and so we can help to show how some of that recording, the kids should, by the time, I would hope that in the 5th and 6th grade, that by the time the kids are struggling with those problems at home, or dealing with those problems at home, they have some way of showing you how they are recording it.
How they're thinking.
How they're
Yeah.
thinking about it. It is the thinking, because the recording comes last. It's just like when we speak a lot and we talk a lot, and then we teach the kids how to read and write. I mean, we don't expect them to write before they've spoken, but we expect them often to use mathematical symbols and procedures before they have any idea of what those mean.
But I really like the idea about asking the questions, because that really puts the onus on them.
Yeah.
Right. Saying, well, now how would you approach this problem?
Right.
What do
Yeah.
you know already?
Yeah.
I mean,
How far
those
can
kind
you
of
get?
questions are really just door openers.
Right.
And then you can get an idea of, you know, where somebody's falling short or where their thinking stops. But, you know, I think also, I spent a lot of time going up to my engineer dad going, I don't know how to do this.
Yeah.
You know, and then he,
Easy way out, huh?
yeah, and then he would start with a thing that starts, we have 10 digits because we have 10 digits. Forget it, I don't care anymore.
My
Father's not
son,
that bad.
my son loves math, and so it's easy to talk to him about math. But I struggle with the way that he records things, so I just don't look at his homework anymore.
Yeah.
And over dinner, I asked him, "So what did you do today?" He's like, "Oh, we were doing prime factors. Oh, what was one of the problems you did?" "Well, 18. The prime factors of 18 are 6 and 2." And I go, "Really? Tell me about that." And then he's like, "Oh, 2 times 6 is 12. Okay, so," and just over conversation, let him spend
about
more
it.
time with the things that he's working on. And I don't know if he goes back and fixes his homework, if he got it right on his homework or not, but it's just a way to spend a little more time with him and talk about it. And that saves me from going, "What the hell did you write down?" And that doesn't make sense.
Right, because that's not very validating.
Yeah, and yet
Yeah.
he's the one that said today, he said, yeah, well, my dad said that any number to the 0 power is 1, because we were talking about powers. I said, right, and then he said, why is that? So, that's a really good question, and then we went into it, so you ask him about exponents, negative exponents.
Yeah.
It was the factorial question that we were talking about.
Oh,
It wasn't
okay.
the power.
Yeah.
0 factorial is
Yeah.
also 1.
Oh, okay.
Somehow.
And that's a great strategy. I was going to mention this on the last question, but a great way to get your kids engaged in that homework is just to get them started
Yeah.
talking through it. Because, like Marilyn said, sometimes it's the recording part that trips it up, but getting them talking through it, a lot of times all of a sudden they'll go, "Oh yeah!" And then they're off and running again. So that's a great strategy for all of those. Even if it's just to talk to them about what they did that day, which
Which
helps
makes it an
immensely.
authentic, real thing.
Right.
Because if it's a real problem that they can talk about versus we did some multiplication.
Yeah.
But if they said, oh, well, you know, I had this problem where I had to, you know, I knew that I only had this amount of building material, I only had this amount of money, and I had to figure, and they're talking about the problem, not the math.
Right.
And
They're
not
trying-
the answer.
And not,
Right.
they're talking about the things that are the most important part, because otherwise it's very abstract to them. And so,
So how hard
Duke
is
it
it
out.
if somebody else like comes in, you know, partway through the NCCL experience?
Yeah.
Yeah.
Well, we have that all the time.
I mean, I had, I'll just speak on behalf of my kid, if he can hear me. He loves math, he's good at math, he went to a Montessori school before this, and that particular school's philosophy was go as fast as you can, do as much as you can, double-digit division when you're 8, okay? And he didn't know what he was doing. He had no idea the meaning behind what he was doing, but he knew how to move the beads. He knew how to record what he saw, but he didn't know how it related to the world, and he didn't have any kind of number sense. So I was working with him the other day, and so he had 3rd grade with me as a math teacher, and I told you it was just maybe a week ago. I said, well, okay, imagine that this is a number talk, and I explained it, and he's going like this. This is what I said. And I'm like, what's going on? And he goes, I'm afraid to tell you. He said, every time I do a problem in my head, I'm setting it up like this. And I'm trying to do it, and that's why I always get the wrong answer, because I drop something. I forget what something, how I borrowed or how I carried. And he said, it's so hard to break that. He says, I can't stop it. He goes, my brain goes right back to that every time. He says, because when you say see the number, he says, you can see the amount, but I see the numbers. And I said, well, so does everybody else at this point. Nobody is seeing 328 objects, you know? And he's like, really? I'm like, no. I'm like, we need to just talk about math in the car on the way home, because there are little questions to ask. Let's not talk about doing anything with a number. Let's just talk about what's the number made of, and how can you break it apart, and what are the most friendly ways to look at a number. I don't want to look at anything ending in 7 if I have to do anything with it. I want it to be a 5 or a 0. 7 is not friendly in this way. And so, you know, and he's like, oh, I think I'm feeling better. But I mean, there are these common sense things to help them kind of wrap their head around what numbers are, because at a certain point, you're not going to be dealing with these when you're 9 to understand what a number means in the same way as you would in group 1. You know, you have to understand kind of where a kid is in terms of how their thinking works. But, you know, he was able in the car to really make progress today.
And kids can come in, I think that basically over the years that I've seen, because I often get kids in 5th and 6th grade, is that they're relieved that they can actually think, that they have the power to think it through. And, you know, I get kids in that are just amazing mathematically, and they just come through. And I get a lot of kids who don't think of themselves as good at math at all, especially a lot of girls by the time they come in 5th and 6th grade that have gone in a more traditional system, who really are very good at mathematical thinking. But they have stopped trusting their ability to make sense out of math. And when they realize they can make sense out of math, or feel very empowered. And, you know, we just talked the other day about something, because we tell the kids all these things like, you can't take a bigger number from a smaller number. Well, yes, you can. You know, you go into negative numbers, and so kids come in with these things. Well, like, take the 9 from the 2. Well, yes, you can take the 9 from the 2. You just happen to wind up with a -7. And that's perfectly fine, and you can deal with a -7 at the end, which I have a lot of kids, that we've seen a lot of kids who've come through our program, who deal with negative numbers in that situation and do it wonderfully without having ever been taught. Let's deal with it at the end. Oh, so I got a -7, and at the end I had to take that 7 away. And then the other thing that teachers will say is, when you multiply by 10, you add a 0. What? Oh, so if I multiply 18 by 10, I add a 0 and I get 180? If I add a 0, what happens to a number? Nothing. Nothing. And yet we tell these kids these things, and then we expect, oh, they're going to make sense. All along they've been told when you add 0 it doesn't change the number, and then at some point they're told when you multiply by 10 you add a 0, and and all of a sudden magically that number turns into 180. And it's like, so they stop making sense out of it because it doesn't make sense, what we say to them. And when they come to us, and I feel, in fact I've got 3 new girls with me this year, and when they start being able to talk to me and raise their hand in number talks and feel that they have that answer, that yes, they're validated, their thinking is validated, it's a turned corner for them. So I love it when we get them in. You know, sometimes it's a little hard. They're looking around saying, boy, they do math really different around here, you know? It's like that there's kind of that, and then they start trusting, and it's the number talks that Kelly talked about, that all of us do, is that I see them reluctant to raise their hand, and then finally a hand comes up, because they put their hand at their chest a hand on their chest with a thumb up, and then I'll say, anybody want to share? And it's that time when all of a sudden that hand goes up. And you say, okay, and you call on that person right away, and you say, well, I'm not sure about this, but I was thinking. And then they go with it, and that's there, then you've got it, you've got them
And
pumped.
in the younger ages, when they come in and they have all these things memorized, lots and lots of things memorized, but then they can't do anything with it. So then it's kind of like breaking it all down again and doing all those things with number designs and number talks and things like that, and then suddenly all those things that they've memorized make sense. So, but it takes putting it all together. That's what
I
happens.
can count by tens. And then the
Right.
kid
They'll
moves
say,
the thing,
well,
goes
how many?
10,
Yeah.
20, 30, you're counting one at a
How many
time.
cubes do we, I wanna know how many, you
Yeah.
know, how many cubes are in this cup? 10, 20, 30, and then at the end you have a pile of 9 cubes, there's 90 cubes here? Really? Is there really 90 cubes here?
Yeah. They can say it, but they really can't use it. You had your hand up.
Yeah, this may be for the older
Yeah.
children. So how much emphasis in, like, how do you balance between making sure that you're on the right track, especially with, like, modeling and things like that? If your model was right and wrong before you go to the end, like your checkpoints, or not when it's too early that you kind of interferes with your thinking. So kind of the balance on where
We have
if
to have
you're
the
on
right
the
answer.
track.
And in the end, we've got to have a right answer. So, you know, there's not like you could just not have a right answer. We're going to get to a right answer. But sometimes we don't get to the right answer at the end of class. So we have to come back to it the next day.
Yeah,
So you
and so
kind
like,
of go
like
all the
with the
way.
penny problems, I try to have, well, at first it was more me deciding, okay, I'm gonna give you 10 minutes and then we're gonna have a check-in point. But then I often will give the kids, so how long do you guys wanna work until I give you a check-in time? Sometimes they're like, we wanna work all class, you know, when they're doing these kind of problems. So, but there's a point where we get together and we share out, and some of the problems, they don't have it even close to an answer yet, and all they're sharing are their strategies. And other times they're like, well, here's where I'm thinking, and other groups like, well, we got this, and then all of a sudden the dialogue starts happening. But before they started off on the weights of the pennies or the time it takes to stack, we had a group check-in point that there's 278 or
Right.
287,000 pennies here, and we talk about that, and the sources of error just disappear because they go back and they look through everybody's charts and go, oh, we're good. So we definitely have those check-in points. Another thing I use is, we call it like a community space. So while they're working, it's really a formative assessment for me. You know, so maybe a kid's, I mean, this isn't the best problem, but say we're doing a problem that involves them messing around with some fractions. There's some quantities in there that are rational numbers. During the problem, they may realize, oh, I know how to do area, I know how to do this. I'm not so sure how to do this part, but I know I have to do it. So they might go up to the board and just write on there, put a sticky note up there that, I don't know how to do this. And then occasionally I'll just stop and say, hey, one of our classmates has something up there, let's talk about that. And usually one of the other kids will say, oh, I know how to do that, and they'll go up to the board and kind of run through it. And so it levels that playing field so we can keep moving at that level of intuition. And a lot of times I'll differentiate my homework that way. So if a kid asks that question, I'll catch them at lunchtime, we'll go over that, and they might get some practice on the fractions while everybody else is playing around with, you know, figuring out the pennies or whatever the problem happens to be.
I mean,
So-
it's really amazing to watch the kids as they're working towards something, and it happens all the time, where they're checking in with each other and they come up with a different answer, and then they try to figure out, and then they'll get somebody else in and say, do you agree with me? And then they have to figure out who went wrong or what. Now, I never say, they'll say, don't ask her, she won't tell you what the answer is. I don't know what the answer is because I haven't done the problem yet. So, you know, I mean, that gets me off the hook completely. And
It's an easy out.
it is an easy out, but they know they need to get the right answer, and they want to get the right answer. They don't want to not have the right answer. They want to all agree. So it really drives it. It drives that. I mean, we've been multiplying with fractions, finding volume in the 6th grade class, and that was, you know, that same kind of thing, is that dissonance of, oh, wait a second, what do I do? What part of the fraction, what happens? And they just walked each other through it. It was just marvelous. And then I stopped the class at some point and said, let's go back over this. So you know, you're constantly dancing back and forth between those two. You're not just letting it go you know, like, oh, it doesn't matter whether you get this or not, because at the end, they have to come away with an ability to do that. And then in my group, the 5th and 6th graders put together a handbook. So after we've worked on something for a while, then we have handbook pages that we put into a 3-ring binder so that they have a reference to go back to it. Because might be a while, like we're doing prime factorization now, it might be a while before we go back and there's something to do with prime factorization, and they need to be able to go back and have that reference.
And they carry those notebooks over and they still pull them out in my room. So they're over on the corner, or the kids, some of them want to keep it themselves. And so they'll ask, can I run out to my locker and get my reference book to go back and think about, you know, something that they know they've learned before but forgot about it and wanted to go kind of check in.
Which is so different than the textbooks with the little highlighted blue box.
Yeah, no.
Yeah.
That, like, you know, you had no part in
Somebody
that.
said today, oh, a seventh, what is a seventh is bigger than an eighth. I know an eighth is 125 thousandths, so a seventh must be bigger than that. And somebody said, a seventh, that has to do with pi. Oh, right, pi is 3.14, because 1.14 is a seventh. I know that's like a seventh, because I remember that story you read about the circumference and pi, and it was like that kind of like all coming together. So I mean, that's the feeling you want. You want them to have that and know that they have a way to think it through and go get it. And they can find it, they can reference it, they can find somebody that can help them to get it.
Yeah. So my name is Melinda Duncan. I have 2 kids here. One is in group 4. She's been in the school for 8 years. And my other one is in group 3. She's been in the school for 7 years. And I just have to share this anecdote because it came really home tonight about the power of this approach. So what I do for a living is that I'm a biology professor at the university. I teach graduate students, science students. So I teach master's and doctoral students in sciences, okay? I had a master's student who works for me who I gave them a pretty simple problem of making solutions and how to make weight volume solutions, and then how to calculate, once you figured that out, how to actually calculate how much you have to make if you want smaller volumes than the base. This guy can't do this problem. When you walk him through it, he can set up an algebraic equation, he struggles with it for 15 minutes, but he can't intuitively say that if you use 4 grams and 100 mils to make a 4% solution, you use 2 grams and 50 mils to make the same volume of solution. My 11-year-old at dinner tonight worked out the problem and looked at me like I was crazy that I would think it was slightly difficult. And the fact that my 11-year-old can outdo the 26-year-old who has a bachelor's degree with very high grades and is a graduate student, I think really tells you why this approach works.
Yeah.
And
We actually did sort of a problem like that for the sophomore.
it just kind of, I expected that she was able to do it, but the fact that she did it so easily just really shows that my expectation my 11-year-old could do this problem was in fact true. Now, I don't know what I can say tomorrow to the grad student, but
You can marry Amelia. Child bride.
But I think that really tells you something about the strength of this approach.
So you mentioned the word intuitive, and that kind of is how I think about a lot of this is, as human beings, I think you started right off with this, is we naturally make sense of our world. We naturally quantify things, and we think about the relationships. If you don't believe it, watch your 3-year-old building blocks. They know what doesn't fit where pretty quickly. Put a brownie down in front of your 3 children and watch the discussion about the fair shares at any age. So we quantify things naturally, and so I think coming at mathematics from that level of intuition, which is really what we're all talking about, allows all kids into the problem, and then there's exit points at any juncture along the way. And really the learning's endless because we could just keep going. And it's kind of that, I think that's a good word, that intuition. It's math that makes sense versus, oh, somebody's got to give me the formula before I can even take the next step. And I think that's huge. And it's just great to have, you know, the kids walking into my class with that mindset and that culture that I can make this make sense and I can do this. And no, I don't want you to even check in with me right now because I got this
Yeah, I
and I'm on
got
a
it.
roll, so.
There are snacks in there, and we'll hang around for a little bit, if you've got questions. But thanks for coming, I know it's getting late, and some of you got to go. Thank you.